Hello, USCAP. Thank you for coming and welcome to A Future for Bit Biopsy and Crypto Specimen Questioning. The goal of this talk is to get familiar with the blockchain as well as to consider pathology use cases. My co-authors and I have nothing to disclose. Don't forget to claim your CME and please turn off your phones. This talk will cover the importance of blockchain, what it is, shed some light on a blockchain future, and proposes a couple of pathology use cases. Off to the first topic. I am a biased enthusiast, and I do think blockchain is the future. Per this article from Harvard Business Review, blockchain could reshape the economy. Experts say we lived in the internet, we live in the cloud, and we will live in blockchain. Hence, many call it the Internet 3.0. What the internet did for information exchange is what blockchain is doing for value exchange, whether it's money, physical assets, services, credentials, etc. It is a disruptive technology adopted by tech giants, with main current applications in asset tracking and the Internet of Things. Features like the practical impossibility of hacking, the built-in privacy, and the superior audit trailing make it come as natural fit for healthcare applications. A Google search for a blockchain in healthcare yields around 15 million results. The Office of the National Coordinator saw the opportunity for healthcare IT back in late 2016 when it announced the Blockchain Challenge and recognized 15 winning papers. Many came from big players. HIMSS formed a working group to evaluate the role that blockchain could play in healthcare IT. It was deemed to be a path to success, where success is artificial intelligence, machine learning, and major new insights, let alone value. One of the most advanced countries in healthcare IT, Estonia, currently has the medical records on a blockchain. Dubai is testing within a government initiative to have all government's documents on a blockchain. So, what is a blockchain? Blockchain is a software. It is not Bitcoin. In the same way Gmail is an email application of the internet, Bitcoin is only a financial application of blockchain. Blockchain solves the trust problem. We usually do not trust strangers, people on the internet, etc. And what we have done so far is to create institutions. In them we trust, so we can interact and transact with the strangers. Institutions like bank for financial transactions, institutions that keep titles of our cars and land, institutions to make sure whoever is practicing medicine is licensed to do so, etc. Having these intermediaries in between, however, costs time and money. And here where blockchain comes to rescue. Blockchain replaces intermediaries, making trusted peer-to-peer interactions possible. In other words, blockchain makes trust a commodity. How is that possible? In a very simplistic demo, let's assume we have an intermediary that happens to be a bank, with which Tushar and I bank. What the bank actually does boils down to keeping a record of who owns how much and how much moves between customers. This is the so-called centralized model, where any interaction between peers goes through an intermediary. Blockchain, in essence, is that very same record that is pseudonymous, meaning our names are replaced through encryption keys. Records in blockchain are also cryptographic, meaning data is tagged with electronic signatures called hashes Electronic signature is something like this. Please note the correlation between changing the data in the white box and the electronic signature between the two red arrows. Notice that the slightest alteration in data changed the signature. Then, the record is distributed. It is owned by everyone. Every 5 minutes or so, depending on the design of blockchain, all new events, transactions in our demo, are captured in a new batch of data, captured in a new block. With time, blocks pile, and the relationship between the blocks are established through the mentioned electronic signatures. Each block has two signatures. The first signature is same as the second signature from the previous block. The second signature is same as the first signature in the next block, hence the name. They are chained. If a bad player alters the record, the electronic signature will change. This will drag a chain reaction that changes other signatures. Consensus algorithms will notice the different chain will be destroyed and replaced with a copy from the consensus. Here it is, a distributed model with real peer-to-peer transactions, where you trust no one except the collective everyone. Security-wise, it is not inventing a more secure technology per se. Rather, it multiplies the current security by the number of participants, which is usually in the order of thousands to hundreds of thousands, spanning wide geography. Another way to understand this is to think of centralized security being as secure as a blockchain made of only one block with only one user. Here's a blockchain in action. It is public and open source. In the same way we have internet browsers, we have blockchain browsers, where you can browse blocks and activity inside them, real time. Here is someone who has given someone else this amount of cryptocurrency. Blockchain has just rendered this trivial transaction a global truth on a global scale. Blockchain is evolving. The data layout, aka token, designed for basic financial services came a long way. Now, they are able to execute transactions upon much more complex parameters. For example, a financial transaction will execute from your digital wallet when GPS data confirms that someone has just given you a ride. In this scenario, you and the someone have replaced an intermediary that is a ride-sharing service. This is the concept of smart contracts. And you got it. When the data layout is that of an EMR or LIS, you replace that intermediary. I opened my last section with what I found about specific pathology applications of blockchain in the biomedical databases. Moving on. Having an entire medical record on a blockchain is technically and politically challenging. However, the current structures are capable of accommodating the much smaller, simpler textual data of our biopsy reports. CAP cancer summary protocols are another good fit. So, instead of browsing a financial blockchain for transaction details, we browse for location of biopsy, type of procedure, things like a grade, ERPR, other immunohistochemistry, molecular, of course. One benefit of this use case would be achieving interoperability between multiple institutions. For remote counseling, for example, the public key would be revealed to the pathologist through the patient themselves or the consulting clinician. Here it is side by side. And given the global nature of these platforms, This interoperability opportunity could accelerate precision medicine and collaboration on clinical trials across the globe. A supplementary use case to reach the data and the much more and complex data like those of our whole slide images would be to include links on the blockchain leading to off-chain traditional servers harboring such data. Due to time constraints, this is my last use case. It repurposes the current frameworks used in other industries, like those designed to capture the life cycle of a vehicle, in order to capture the life cycle of a specimen in our lab, where every transaction represents a step in processing the specimen that is time-stamped. I leave you with a glimpse of the future, where many companies continue to live as smart contracts on the blockchain. I invite you to attend the Blockchain Summit at UIC in May. I ask you a question, and I thank you much.